Hello and welcome to this presentation on open source LLM ecosystem at Hugging Face. The reason why you are seeing an asterisk on open source is because certain elements in this presentation can be open access rather than open source. The difference comes from the fact that some licenses do not allow commercial use or distribution, but still the element is distributed openly. So with this disclaimer, let's get started. But first, why open source machine learning is all you need? Comparing to closed source, firstly, you have absolute control over your model. With the closed source APIs, the problem is that you do not have access to the model itself. There is a lot of over-engineering over that model, and you do not know the system prompt of that model, for instance, and the model or the system prompt can change by time without you noticing it. If you have a working system behind the gated API, it might not work all of a sudden, or it might get lazy. It's better to have the model all to yourself and have absolute control over the model. And secondly, you have also control over the data during the inference. You do not have to send your data to a third-party provider because your data is important. One cannot guarantee whether they are training a model with your data or not. And lastly, you can shrink the model for small device deployment if you wanted to, because you cannot deploy a model that you do not have the control over. So how can you find the right open source model for yourself? If you go to hf.co/models, you will find the model repositories. And on the left-hand side, there is tasks. And on tasks, you can filter for text generation, and you will see a lot of models for yourself. And before moving on, let's see three types of text generation models. So firstly is the base models, aka pre-trained models. These are LLMs trained on compilation. And secondly, there is chat models. These are base models aligned, fine-tuned on chat data. And thirdly, there is instruction models. These are base models fine-tuned to follow instruction. And the difference between these two types is the data that is given to these. How can you find these three types of models on Hugging Face Hub, and how can you evaluate them? So there is OpenLLM leaderboard. If you Google that up, you will find it. You can filter for model sizes because you might have a lower budget for model serving. You can filter for the precision because you might not be able to host models in float 16. You might want to have a model in 8-bit or quantized with GPT-Q. And there is model types. There is pre-trained models, models fine-tuned on domain-specific data sets, or chat models, which I have gone through. There are different techniques used for aligning the language models to be more helpful. And you can also filter for different benchmarks, depending on what you would like your model to be optimized on. And in here, you can rank different models on different benchmarks. And if you feel like best of all worlds, you can just rank them based on average. So for instance, if you would like to your model to fit inside the T4, you might want to filter for 3B and 7B parameters. If you would like something even bigger, you can filter for 60 to 70B, and you can see different types of model sizes versus the NVIDIA GPUs that fit in. And if you would like to compare them to chat models, there is LLM's Chatbot Arena. So LLM's Chatbot Arena works as following. People are voting for model outputs without seeing which model output belongs to which model. So it's completely fair. And then this ELO voting results is ranked. And you can see here, for instance, there is a bunch of models that are open, like Mixtral is open, Yi is open, Q1 is also open. And if you have found your model and if you don't know how to deploy it, you can use Text Generation Inference Toolbox. It's incredibly powerful. For each different types of LLMs, it has optimized inference images. It provides quantization support with bits and bytes, GPT-Q, AWQ. For inference, it provides token streaming support through server-sent events. And you would like to serve model in different devices, you can shard the tensors and then have tensor parallel inference. So you can serve the model on multiple GPUs without you specifically dealing with that and more. Another cool thing is Chat UI. So this is the open source chat frontend made by Hugging Face. It is an open repository that you can find on GitHub that contains a chatbot UI essentially. And the Chat UI and TGI is currently powering Hugging Chat, which is this hosted application where you can try different LLMs, which I will show. But for instance, this is a recommendation for visiting Istanbul in winter. This is chatting with instruction fine-tuned Mixtral. And if you feel like it, you can try a variety of open models in Hugging Chat. It's very cool because you do not have to serve it to try or play with it and find which open model is right for you. Hugging Face takes care of that. And if you feel like building assistants with system prompts on these models, you can do that with Hugging Face assistants. There is a variety of assistants on Hugging Chat, and if you feel like it, you can create yours. You just go to Hugging Chat, create an assistant, pick a base model, and also write your system prompt, and then voila, it's ready to converse. And if you feel like customizing your model, there is a bunch of libraries that you can use for fine-tuning, quantization, and more. Transformers is the main base library that all the other libraries are building on. So essentially, all of these models are implemented in Transformers with a very helpful API. Each of these models have model classes. For instance, for text models, it is called causal language modeling. So you see, for instance, Mixtral for causal LM. And you can take these model classes and use them for inference or fine-tuning. Another library with an open source LLM ecosystem is Transformers Reinforcement Learning Library, TRL. And it contains many of the alignment techniques that we use to align the language models to be harmless and helpful. This includes supervised fine-tuning, direct preference optimization, and more. The most popular one these days is direct preference optimization. And so I have added the class that is used to train DPO. And in here, you initialize the class with the base model. And then you add the same model oftentimes for DPO as the reference model, but with the frozen weights. And then you pass the training arguments like learning rate and so on. And training data sets, the tokenizer of that model, and whatever loss you would like to use, and then call train. This is a simple API that you can use for training DPO. Another library is called parameter efficient fine-tuning. So for instance, LoRa is one of the most popular techniques that are used these days to adapt language models. Like essentially what you do is you have a lower rank matrix to track the changes during the fine-tuning instead of doing full rank matrix fine-tuning, which is more computationally heavy. Parameter efficient fine-tuning library has very useful abstractions in order to save up on the compute. And this includes many other things, like for instance, model merging is just to take two models and merge them, and this can be even done on CPU. And it also supports bits and bytes. For instance, you can load the model with the 4-bit weights and then do low rank adaptation on it. And it also has a lot of techniques, for instance, prompt tuning, prefix tuning that was introduced by Stanford NLP back in the day. And if you have any questions, you can ask them below this tweet. And also join the community at hf.co/join/discord, and I will see you again.